Okay, wanted to make a quick video to answer some questions about pulse width modulation. Pulse width modulation is basically a way to fake an analog output on a digital microcontroller. And the fact that we can turn the output on pretty quickly, as the LED here blinking shows, you can create any analog voltage by altering the time on and time off of an output pin. So an Arduino that we're running here has an output of 5 volts, but we can fake any voltage from 0 volts up to 5 volts by using pulse width modulation, or turning that pin in a on and off fashion in a controlled sequence. So here we're doing a 50% duty cycle. Now the output of the Arduino is not exactly quite 5 volts; it's about 4 1/4. So turning it on and off of 50% gets us about 2.12 volts. And if we go over here to our oscilloscope, you can see that it's about 4 1/4 volts is the peak, and then it goes down to 0 volts. And the time spacing between the time on and the time that it's off is about equal at 50%, so that makes a 50% duty cycle. And it's on for about 50 milliseconds and off for 50 milliseconds, which makes it about a frequency of about 10 hertz. Here the oscilloscope's measuring about 9.9. Now the way we're doing this one is using the MCP4725 digital to analog converter breakout board from SparkFun. And so it communicates with the Arduino via the I2C communication protocol. And all we're doing is sending a command to turn the pin on to the output pin, drive it all the way high, which is indicated by the last two sequences of 255, 255. Drive it very high, and then if we zoom out here, and then if you notice at approximately 50 milliseconds later, which is the width here, we send a new signal, a new digital sequence to tell the pin to turn off. And if we go in there, you'll see, oops, there it's FFF again, so that's high. Let's find the next one down here. Will be there we go, 0, 0, 0, 0. So now we turn and go all the way down to 0 volts out. And so by doing that in a sequence rapidly, and each of these represent a sequence of all ones followed by all zeros, we are turning the E, and we're doing it at 50 milliseconds in between. We get the equivalent of sending about half the output voltage pin, which is again 5 volts. In reality, we're getting about 4 1/4 volts out. So with 50% duty cycle, 4 1/4, half of that is about 2.1. So we're faking an analog out by using pulse width modulation, turning a digital pin on and off in a very specific sequence. And that, in a nutshell, is pulse width modulation. And actually, this is the analog output of the digital to analog converter on the oscilloscope. And on the logic analyzer, that's the communication between the Arduino and the MCP4725 DAC to control it. And then the LED's there just to show you that it's switching. And then the multimeter shows you what the digital, or excuse me, what the analog output reading is. And that's it.